Everyone, welcome to Data Science Community. In today's video, we are going to discuss a part 2 of Bitcoin price prediction. In this video, we are going to see how we can apply a machine learning model on our data. Okay, so basically in part 1 we are already discussed about data set. We perform data analysis, feature selection, and EDA. Okay, so we are covering that much part in our last video. So in this video, we are going to see whether we should buy the Bitcoin or not. Okay, so it will predict whether you should buy your Bitcoin or not, or stock, okay, based on the price. Okay, so we already discussed this. We already used above 4 libraries in our last video. Now we are using these parts. Okay, so what are they? So here sklearn is the main library, okay, from which we import our model selection. By using this model selection, train, test, split, we can split our data in train and test sets. Okay, by using this pre-processing standard scaler, we are increasing our accuracy. Okay, so it will range our data. Okay, basically it will standardize our data. Okay, and linear model logistic regression is our first machine learning algorithm which we are going to apply in this data set. Second is SVC, which is support vector classifier, XGBoost classifier, which is XGB classifier. Okay, and the last is, here we are using metrics. Okay, so here we are using metrics to check the accuracy of our model. Okay, and here in this video we are checking our accuracy by using confusion metrics. Okay, so let's start. Okay, let's quickly run all these cells. Okay, so sorry. Okay, these all for the EDA part which we covered in our last video. Okay, and this is our heat map which is showing the correlation between columns. Okay, and from here we are going to start. Okay, yeah, from here we are going to start. These were our features. Okay, and on the basis of these features we have our target. Okay, so we are storing this feature in these features into this feature instance, and our target variable in this target instance. Okay, and we are storing our standard scalar function or object in this scalar instance, and we are assigning this feature with the scalar dot fit transform features. We are applying this standard scalar because here we are using scalar instance. Okay, here we are using scalar instance which stores this standard scalar, and here we are using scalar dot fit transform function of this standard scalar function, so that it will transform our features into a standard values. Okay, and here in this line we are dividing our data in 2 groups. Okay, here xtrain, xvalid, and ytrain and yvalid. You can also write xtrain and xtest instead of valid, and here you can write ytest instead of valid. Okay, so here we are dividing our data into test and training. Okay, test and train group. Okay, so training data is provided to our models to train or to learn from that data. Okay, and by using test data we can check whether our data is working correctly or not. Okay, so here we are providing, wait a second, so here we are providing our features and target value, and here we are providing the test size which is 0.3, which means it will divide our data into the ratio of 3 and 7, which is 70% is training data and 30% is test data. Okay, it is the ideal ratio for dividing test and training data. Okay, so here in our training data we have 899 rows, and in our test data we have 1899 rows, and in our test data we have 814 rows. Okay, so after selecting the features to train the model, we should normalize the data, because normalized data will lead to stable and fast training of the model. Okay, so here we already normalize our data, and we are splitted our data into, here I mentioned in where it is, yeah. So here we are dividing in the ratio of 70 and 30. Sorry, 70 and 30. Okay, now let's model deployment and evaluation. So let's do model deployment and evaluation. Now it's time to train some machine learning models, which we are using is logistic regression, support vector machine, XGP classifier. Okay, so then based on their performance on the training and validation data, we will choose a machine learning model. Okay, so here we are storing all the models in a list. Okay, so here we have logistic regression, SVC, XGBoost, okay, which is XGB classifier. Okay, and we are storing all these algorithms in our list. Okay, and we are applying this loop on this list, which named as models. Okay, and here we have models I, which means initially the value of I is 0. So first we apply logistic regression and fit these data, which is a training data, to logistic regression. So basically by using fit function you can train your model. Okay, and after training we are writing the model name here, and here in this we are using this matrices which we imported earlier and checking the accuracy score of this logistic regression. Okay, and here we are also checking the accuracy, here we are checking the accuracy on the basis of training and test data. So y train is training data and predicted probability of this data. Okay, and here we are checking the accuracy on the test data. Okay, so here we have our training and test data both. Okay, so as you can see here as an output, the logistic regression gives 53% accuracy on training data and 50% accuracy on trained data, and support vector machine give 53% accuracy at the training data and 48% of accuracy on the training data. Okay, and XGBoost, XGB classifier. Okay, so it will give basically it will give 94% accuracy on training data and 46% of accuracy on test data. Okay, so here we are checking the confusion matrix. So here you can see that this is the confusion matrix for the above model. Okay, so XGBoost gives us the highest accuracy. Okay, so that's why we are checking confusion matrix for the model at for XGBoost. Okay, so this is the outcome for the confusion matrix. Okay, matrix, here we have RTP, which is true positive. Here we have FP, which is false positive, and here we have FN, which is false negative. Here we have RTN, which is true negative. Okay, so basically TP is the true value which is predicted as true, and FP is false positive, which means the data set is having a true value but it will predict as false, and false negative, which means the value predicted as false but it is true in our original data, and true negative means the value predicted as false but in actual it is false. Okay, in our main data set it is true, it is false, and in predicted value it is also false. Okay, thanks for watching. Like, share and subscribe for more such videos.